All right, so this lesson we're going to talk about how to prove our fundamental trig identities, and this can be a bit challenging. So really what you want to look at is figure out what you can do using this chart here. So we'll kind of reference this throughout this video and actually really this unit. And I'll put this on your assignment so you have it as a quick reference. Okay, so how do we prove identities? We're going to kind of go through the steps. First, proving an identity means showing that both sides of the equation are the same. So you did some proofs in geometry, so hopefully this kind of makes sense. But how do you want to attack these? You really want to pick one side of your trig identities and work with that until it looks like the other side. So usually you want to start with the side that is more complicated and make it look like the easier side. So let's just kind of take a look at one of these here. So if I look at this first one, tangent theta over secant theta is equal to sine theta. So in this instance, I would say this is more complicated. So I'm going to work with the left side of this equation and try to make it look like sine theta. So our last line should actually be this left side should be equal to sine of theta. Okay. So now when you do this, you want to reference again up here. So I have tangent and secant, and I want to make them look like sine. So you're going to come up here and you're say, where do I see tangent? Okay, I've got tangent a couple of different places. I've got it here, and I've got it here. And I also have secant right here. Now, sometimes they could be squared. You might be dealing with some of these here, but I'm going to start with these other ones. Now, I know that I have to get sine theta. So this is kind of an indicator to me that I'm probably going to want to use this one because it has sine in it, and this one right here does not. So I probably don't want to use this. So I'm going to use maybe these, some combination of these two. Okay? So let's go back, and then I'm going to just try some stuff. And now sometimes you're going to go through and you're going to start these, and it just won't work out. And that's okay. You're going to have to be okay with making mistakes and going down the wrong path. That happens fairly regularly with proofs. So that's one of the challenges with these, is it can be a little bit frustrating. Okay, so let's start with tangent. We know that tangent, we just said up top, I suppose it'd help if I had my pen on here, is sine theta over cosine theta. Now, secant, I could leave that, but I see the cosine in the top, so I'm going to rewrite this secant as 1 over cosine theta. So I'm just using the chart to make it look like the right. So now I have this, and again I want it to equal sine of theta. So now what can I do to kind of keep navigating through this? So first of all, sine of theta divided by cosine theta. This is divided by 1 over cosine theta. In other words, that's the same as multiplying by the reciprocal, cosine theta over 1. Okay, so now if you recall, we're multiplying here. If you have something in the numerator and the denominator that you're multiplying, this only works when you're multiplying, these two things can cancel out. Okay, so now I have sine theta on the top and 1 on the bottom. So that just gives me sine theta. Now that's what I wanted. You could see I wanted it to equal sine theta. When you are doing the proof, now that we've proved that the left side is there, we want to say that this left side now equals what we wanted it to on the right side. So I'm going to say sine theta is equal to sine theta, and then this is my last line of my proof. And so you've just proven that identity. Okay, so that's one of the more straightforward proofs. Let's kind of take a look at another one here. It's got a little bit different thing going on, but it's just getting used to trying these. Okay, so this one says 2 is equal to 2 times cosecant squared theta minus cotangent squared theta. So again, when I'm doing this, I want to come back up here and look at, I want to go back to my sheet and look for cosecant squared or cotangent together. Okay, so cosecant And sometimes they won't always be together. You might have to look around. But if I look right here, these two are actually put together already for me. So I'm going to try using that and see what happens. Okay, so I'm actually going to write this over here. I know it said up there cotangent squared theta plus 1 is equal to cosecant squared theta. Kind of running out of room there. Now that's not what this, now those are together, but that's not what this says here. However, I can rearrange this right here a little bit. And what I can do is I need to get cosecant squared minus cotangent squared. So if I subtract cotangent squared theta from both sides, okay, these would cancel, and I would end up with 1 equals cosecant squared theta minus I'm running out of room here, so I'll just write it cotangent squared theta. So now this right here is actually what it says right there. So according to what I just wrote, cosecant squared theta minus cotangent squared theta is equal to 1. So this is an important thing, is understanding that these trig identities, these trig identities right here can be manipulated and moved around just like any other equation. You can subtract something from both sides so you can get it to fit more what you need. So that's what we did here. And so in place of, I have that work there. So now I can write 2 is equal to 2. I now know that this right here in the parentheses is now equal to 1. So 2 does equal 2, and I've just done my proof there. So there's another one. Okay, so there's a couple of ones just introing how to work a proof, and you'll notice this one I actually worked with the right side because it was a little bit more tricky, and we want to make it look like the left side. So pick the side that looks a little bit more complicated and make it look like the other side, okay? All right, I'll have another video with a couple more of these for practice. I hope that's starting to make a little bit of sense. All right, see ya.